Okay, so now we are going to enter into the first order second movement method FOSM, and how to find out the reliability index beta, which is a very important part of determining our reliability. Okay, so first and foremost, I'll just continue from where I have stopped in the last video. So probability of failure is the probability of R being less than S or S being greater than R. So this is the probability of failure, we already know, and we have seen the margin of safety function M G, a function of G, a function G of my resistance and my action, which is equals to R minus S, right? So, and I have also seen that probability of failure is going to be integration of all the probabilities, individual probabilities, saying integration of all the individual probability distributions as long as G is less than 0. So this was what my probability of failure is. So in terms of R and S, now I've already told you in the previous lecture that if I know R is also dependent on x1, x2, x3 dot 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 xn, S also dependent on all the quantities, the material and the geometric properties, then in that scenario I have M as a function of R and S and also G as a function of R and S. So in that scenario, what's going to happen is my M, M, since M equals R minus S, so the probability of failure shall be till M is less than 0. So probability of failure is going to be as long as M is going to be less than 0. Once N becomes greater than 0, there won't be any failure. There's going to be safety in that scenario. So how can I find out whether M, how to calculate the probability of failure, the probability till the point where M is equal to 0, or from minus infinity to M equal to 0. So you can already guess that we have used previously the cumulative distribution, or the cumulative probability. So the cumulative probability phi that we have discussed before is going to give me the probability of failure. The probability of failure is going to be the cumulative probability phi. Okay, so cumulative probability phi. So we know that cumulative probability, I'll just just a side note here. Okay, so we already are aware of that the cumulative probability phi till any point x is going to be x minus mu of your distribution, the mu of the distribution divided by the sigma of the distribution, right? The cumulative probability is going to be phi of x. X is that point, till what point you want the cumulative probability, minus mu of the distribution, the mean of the distribution, divided by the standard deviation of the distribution, right? So in this case, I want the probability till my M is less than 0, which means from minus infinity to the point 0. So 0 minus mu of M divided by sigma of M, right? So this is going to, what is it going to give me? Into minus mu M divided by sigma M, and this is known as the reliability index phi of minus beta. So beta is right here. It's important, very important. The reliability index beta equals mu M divided by sigma M. Okay. Alright, so in first order second movement method, the FOSM, we actually need to determine the beta. And why is it called the first order second movement method? When we will do one sum, we will see how this is required, like how this name came up to be. Basically, I'll just mention here the first order second movement method. This term comes from second movement we are already aware of. These are the variance. Okay. Second movement is the variance. We are already aware of the second movement is variance. First order, why? Because we will be using, in order to calculate the derivatives, we will be using first order terms of the Taylor series expansion. First order terms of Taylor series expansion. So basically Taylor series expansion. Okay, Alright, so basically we are not going to directly take up terms from the Taylor series expansion, but we will be using derivatives at certain points of time, and we know that these derivatives we have found out using the first order terms from the Taylor series expansion. If you remember, the Taylor series expansion did something like fx plus h, which means the value of the function f at some point x is given, and another neighboring point plus h, very close to this neighboring point, is going to be fx plus f dash x of h. Okay, sorry, plus I can go on f double dash x into h square by 2 factorial. Okay, and I can just keep on going in this Taylor series expansion, f triple dash x h3 by 3 factorial, and so on and so forth. But when we are calculating derivatives for our FOSM, we will be using only till the first order terms. The first order terms only we will be using. We won't be using it directly. We won't be able to understand that we are using it. In order to calculate the coefficients, we will be using derivatives which are actually derived from our Taylor series expansion first order terms. Alright.